everyone. This is just a recording of the session that we had last week with the residential students on BIM. You will find that it's a very shortened little section, and everything that you will have to study is within the slides, and I'll highlight what the important things are. So the main thing is just a couple of background things that we just need to look at, and you would remember from your first year where we started out with the origins of the quantity surveyor and how it spread out of the master builder functions, basically, where quantity surveying is actually a specialization of the architecture profession as it developed later on, where the client started to request quotes beforehand from contractors. Contractors started colluding, and then clients started to catch on to that, and then appointing independent QSs to manage that, to check whether that quotes that are supplied are actually in line with what is being presented. So just a bit of background on that, and then just the finalization of that. That's just a bit of background, but the main thing is we've always been working on BIM and with building information modeling per se, and it's just the maturity levels that has been that differs from where we used to work on paper-based type of architecture drawings, getting digital drawings and getting 3D models to measure from, etc., etc. Now, architecture is mainly the forefront with any design process, because they are the visionaries of whatever building is going to be constructed. Similar, the engineers is the visionary of any civil construction that takes place. So they had quite a few tools that also developed over the years and that was utilized, and this is typical details that would have been produced. So, but the problem with this was that making any changes was had a big impact on the process, and any amendments also caused a lot of problems down the value chain. The way that models were presented was time-consuming hand construction, cardboard cutouts, etc., etc. I just mentioned to the residential class that the architects still do the same design of model production through construction of physical models, still for that hand-ear coordination and looking at the design, building it basically from scratch just to learn the process. Similarly, we do the same when we teach you how the measurements works and everything, because most of the programs that we use is based on these principles, and we found that using these principles or understanding these principles are much more important than actually knowing the actual software, because if you know the underlying principles, the software can easily be learned. But as we progress and as the programs get more user-friendly, this process can shift slightly to the other side. You will see that I just included some highlights of what the potential is of BIM. The visualization side is where you can have clash detections, etc. And this was a very interesting scenario where the carpeting actually caused a bit of trouble with the steps. But most of these items one can actually mitigate during the construction process. If the contractor highlights these challenges, they can easily, with a request for information, get the necessary information to prevent anything like as shown on this slide. So the short and the long of building information modeling is that there is information produced by one stakeholder, then transferred to another stakeholder, And each time that it's transferred, there's some sort of information loss that takes place. So the main thing what BIM wants to eliminate is basically the loss of information to lessen that process as much as possible. And obviously, it also depends on the involvement of each stakeholder in between. Usually, we find that most of the information that's lost is during after construction and handing it over to the client or the facilities manager, where a lot of information is lost. So, looking at just the potential in the 1990s, this is how a typical site office may have looked, whereas in that time already aircraft was being produced using building information modeling or similar processes, already not using any paperwork for the design and manufacturing process. Now we know that manufacturing is a different process because it is the same product that's produced over and over again. It's not like construction where we have a new product produced each time, which just places a little bit more emphasis on the transfer of information. Also, on construction, it's every time a new team that's put together to actually transfer and do the necessary designs. So for this section of the study material, the main thing that I want you to understand at least is that we've got different maturity levels where the maturity level of 0 is still mainly CAD based or hand drawing type of technologies. We still use quite a lot of CAD drawings that's usually supplied by architects to QSs or construction managers, etc., etc. There has been some progress in that aspects, especially engineers, for instance, that use Revit or any other design of Civil 3D, which assist them in the actual design process. Architects use other programs like ArchiCAD or Revit as well, which usually assist in the visualization of information. Some architects also called on, it really depends on the uh, incentive for them to produce information-rich data to actually produce new or intelligent models to the subsequent project managers and quantity surveyors and facilities managers to actually utilize. So the main thing that I want you to understand for this module is that yes, we've got different BIM levels and of maturity where we kind of in the entry level of or on BIM level 2 at this stage, and this might also differ from your experience in the industry. It really depends on the, the project for one, as well as the requirements from the client, the project team, etc. So it's a bit more dynamic than just one person adopting this. I'll elaborate a little bit on my experience on the whole process. So you will have in BIM level 2, you will have 2D drawings and 3D drawings mostly produced or models, but it really depends on the information behind all of this. Then you will find BIM level 2 is this is where you have integrated information that's shared on a BIM iCloud, for instance, where you will have a model with all of the information on from which you can use Dimension X or Cost X, for instance, to actually do the measurements on. It's quite handy. I've received some drawings like that before, but unfortunately, that there's still a bit of a process that needs to that we still have to go through to have the necessary BIM standards in place. And then we have level 3 where the existing building and the design actually speaks to each other. So that's where you actually have a digital twin where the one speaks to the other and the actual building influences the design, and you can actively measure and manage that building through the BIM model, not having to be physically on site. Then this is just another visualization which just also assists is we have BIM level 2, mostly drawing, paper-based drawings, CAD drawings, then going over to a 3D visualization, and then finally going up into an iCloud type of BIM environment where everyone does their part on the model. And then secondly is the integrated feedback between the physical and the digital. Okay, then the other thing that I want you to be able to understand is, yes, we've looked at the BIM maturity levels, but it differs from the BIM project lifecycle, where you would have a typical program or design and on a BIM model and have the conceptual drawings done, then the detailed design is still done on a 3D model visualization platform. The analysis, everything takes place on that platform. The documentation is pulled from this model, and then manufacturing takes place after that, and then 4D BIM and 5D BIM, on which I'll expand a little bit later on, is then based on where the actual construction takes place. The construction logistics is then also planned using the BIM model, and then the operational management maintenance is then conducted on the BIM model together with the physical structure that has been built. Something which is left out here, this will be 6D BIM. Okay, and then any renovations will then take place, or the design can be used for that, or then the demolition of the asset. So then the other thing that you need to be able to convey to me is that you understand that the 3D BIM is mostly concerned with the architects or the engineers, the actual design of the model. 4D BIM is where you've got the construction managers or construction project managers that does the programming based on the model. And then 5D BIM is a quantification of from the BIM model. And then 6D BIM is the life cycle planning, which is the facilities managers, etc., etc. Then I've just added a couple of videos. We watched the one video, the first one in class, and it just relates to technology as how it has progressed and stuff, items that we haven't really realized yet, but has revolutionized the way that we look at how we conduct our business. For instance, PDFs, how it revolutionized our way of thinking on how we transfer information to site and from site on drawings, etc., which PDF just revolutionized basically. Even just stitching a tender document of 600 pages together on one PDF was a major step forward for the construction industry. Okay, and then I just included two other videos here, the one relating to 5D BIM and 4D BIM, sorry, and 5D BIM as well, which just gives you a bit of background on the differentiation between those two. And okay, then I included the hype graph for the technology. So with any new technology that's being developed, there's usually a big hype. As we could see with BIM, everyone thought it's going to revolutionize everything that we do, but we realized that, okay, there's a bit more work the architects have to assist us with more information on the actual BIM model to assist us in actually utilizing our programs that we use on the model, like Cotindemex or Costex, for instance. But once we've gone through that, there is a place where we reach a bit more productivity. We can see this from the research data as well, where in 2012 it still was a little bit of information, and then suddenly it became a catchword, BIM modeling, and then here in 2016 it kind of peaked, and then it went down again, and we're kind of at the same levels as we were in 2017, where we're still investigating the practical ways of breaking down barriers between the different team members. Okay, then I just want to give you some background on where I found myself on the process. And this is a very interesting drawing that was drawn in 1899 by a French philosopher of architect, sorry, who um, um, had a vision of how things might look on a construction site in the year 2000, where someone would be sitting in an office and then controlling machines doing the construction on site. And we can see we've progressed quite a bit towards that, but we aren't there just yet. Then what I just included here is construction 4.0 type of technologies and how it actually influences and the big influence that BIM will have on these technologies. So this is from Sauni, a book that was published in 2020 on construction 4.0 or the fourth industrial revolution type of technologies for the construction industry. But you can see in short, the how it is seen how the progress will go into the future is where we will have existing assets that will influence how we do design. The design will be a digital interpretation and enhancement of the environment, and then taking it back to the physical. And then from this physical, it will go back into the digital, and the process will run over and over again. Then I also just included a picture of how BIM it serves as a catalyst or a middle man, if you want to call it that, between construction 4.0 type of technologies on the one side, which we have digital design, which influences the BIM model, which is then taken over to the physical construction area. And this is quite an insightful diagram on showing how pivotal building information modeling can become in the future. So the big advantages of course, during the design process is clash detection and finding um, challenges between the different trades beforehand, the quantification thereof, etc. You can just see some practical examples of clash detection that assisted where the plumbing installation was done, allowing for the air conditioning to actually go, run underneath the existing design. Then this is just a project that we worked on now recently here in Zastron. This was just a visualization. I don't know if this will actually play. Let's see if it can play. Oh no, it didn't want to play. So it was just a representation, but it's a typical example of what we're currently getting. We're getting a lot of nice 3D designs from architects, but it doesn't have real information behind it. So the previous picture was actually a nice panning shot of the entire project, just looking at how it will look on site. And then I also just wanted to show you this representation. This is quite old. It's actually 8 years old, or yeah, I think it's 8 or 9 years old. Is a project that we had here in Hevelsig, a planned pressure tower, and the visualization actually assisted us quite a bit in just seeing how the shadows will actually be cast over the adjacent or surrounding buildings on top of the hill. But still, um, it showed us a lot of detail on the design, and it gave a lot of perspective on what we had to measure. And we were quite excited about it, and we actually got Costex or the Dimex version for South Africa for the 3D design, 3D quantity tables. But when we actually got the information, it was still just objects that still had to be converted back to 2D drawings to actually do the actual. So this is just basically the mention of that. So yeah, in a nutshell, um, the main thing is on 3D BIM, what I want you to understand is firstly, it is not a technology, it's a combination of technologies, and on different people working on different sides. We've got different motivation. We don't have government climbing in and making policy to have certain standards at a certain time, which is one of the big barriers for South Africa. Secondly, I want you to be able to distinguish between the BIM maturity levels, the project life cycle, and the different role players on BIM. So I want you to be able to recognize that 3D BIM is mostly for the design, 4D BIM for the programmers, 5D BIM is for the quantity surveyors, and 6D BIM is for the facilities managers. So I want you to specifically be able to convey the difference between those two factors. So I hope this has been helpful, and please let me know if you've actually worked on a BIM project, or have been using these type of technologies on the specific areas that you work in. It would be interesting to hear from you. Thank you very much.